Welcome, Hornets. Thank you for joining me today. Today we're going to continue with our second general practice for integration. This has various integrations of varying styles, and this is part 2. So if you have not seen part 1 with numbers 1 through 4, please be aware you will want to go back to that. I will be doing numbers 5 through 8, and you'll notice they are up here right now. So we have one integration of an absolute value. We have one integration where we will divide the terms. We have an integration that is going to be using a distribution, and then a u sub in number 8. Okay, so here we go. Please make sure you have a screenshot for this if you have not already done so. Let me just give you a moment. And for those of you who want the bottom part, alrighty, let's go ahead and begin. So we're going to be taking a look at number 5. Number 5 is the absolute value from 2 to 5 of 3 minus the absolute value x minus 3, the quantity plus dx. Now, there are two different types. We have graphing, and a lot of people find that graphing is the easier of the two processes. And if you are graphing, I would change it into y equals negative absolute value x minus 3, the quantity plus 3. This puts it into our m equals x, or m times the absolute value x minus h plus k form, where the vertex point is h and k. That means that I'm looking at 3, 3 as my point. So if you're using the graphing model, I'm just going to go ahead and I'm going to locate 3, 3. And my slope is a positive 1 on the left, and a negative 1, 1, 2, 3, a negative left on the right. Alrighty, here we go. We're now looking at between 2 and 5. So 2 is right here, 5 is over here. And if I were to plot these points, this would be 5, 1, and this would be 2, 2, from 3, 3. Now our goal is to find the area of this figure. You'll notice it's kind of a lopsided house. And I'm going to go ahead and I'm just going to find the various areas. I'm going to divide it in half and look at 2 triangles and 2 rectangles. This rectangle is base times height, 2 times 1, and has an area of 2. This rectangle is height of 1, length of 2, 2 times 1 is also 2. This triangle is 2 times 2 divided by 2, and that also gives me an area of 2 using 1/2 base times height. This is 1 times 1 divided by 2, and therefore this is a half. We're now going to add it all together, and we will end up with 6.5. Now, if you decided to use the second option is by far more work. This is the analytical method. And in order to do that, we're going to have to find our piecewise function for f of x using our pre-calculus skills, and therefore I will have x for x less than 3, and I will have a negative x plus 6 for those x values greater than or equal to 3. That would force me to integrate, and now I would be integrating from 2 to 3 of x dx, and adding to it the integration from 3 to 5 of negative x plus 6 dx. This will give me 1/2 x squared from 2 to 3, and that would be 9/2 minus 2. 9/2 minus 2 would give me 5/2. Then I have plus, and I'm now looking at negative 1/2 x squared plus 6x, and we're going from 3 to 5. And when we do this, by the fundamental theorem of calculus, we're going to be looking at plugging in the 5. That's going to give me negative 25/2 plus 30. And then we have to subtract, plugging in the 3. That's going to give me negative 9 halves plus 18. And I'm going to need to simplify this, so this first piece will simplify to 35 halves. The second piece actually subtracts, and we end up with a negative 27 halves. We're now going to add this all up to get 13 halves, and our answer is still 6.5. Now you'll notice this is by far more work than just finding the area, which is what we did to graph. It is up to you. You have to decide, but just remember, try not to do too much work. The more work you do, the less time you have when you really encounter a problem. So don't waste your time on the AP test. This brings us to number 6. Number 6, if you recall, gave us this fraction. So we had from negative 8 to negative 1 of x minus x squared all over 2 cubed root of x dx. And what we want to do is we want to separate this into 2 separate terms. So negative 8 to negative 1 of x over 2 cubed root of x dx. And then we have a minus negative 8 to negative 1 of x squared over 2 cubed root of x dx. We're now going to have to use our laws of powers. And when we use our laws of powers, I'm going to first bring out the 1/2. And then I'm going to look at it as 1 whole minus 1/3. 1 whole minus 1/3 is using the laws of powers, and we end up with x to the 2/3 power dx. 1/2 comes out, negative 8 to negative 1. Once again, I'm looking at it as 6. Notice this is going to be 6/3. We're going to take away 1/3, and that's going to give me x to the 5/3 dx. Now this is where I start integrating, and I integrate normally. So 1/2 plus 1 makes 3/5, and we have x to the 5/3 from negative 8 to negative 1 minus 1/2. This is going to give me 8/3, so 3/8, and x to the 8/3 from negative 8 to negative 1. We're now just going to kind of clean this up. We have 3/10. We're going to plug in negative 1. That's going to give me negative 1. We plug in the 8/3, the negative 8 into the 5/3. That's going to give me negative 32, and with the minus from the fundamental theorem, we have plus 32. Then we're going to have to subtract. We have 3/16. We plug in the negative 1, and now we're looking at 1. Now we plug in the negative 8, and we get negative 256. We now get, simplify this, and we have 3 times 31/10. And we're looking at double negative for 3 times 255. This is 16ths. And when we do this, we get 744/80ths plus 3,825/80ths. That's getting my common denominator. I add them together for 4,569/80ths, and this is 57, and we have 16ths, I believe, 1125. And these would be my answers for number 6. Let's go on to number 7. Now, number 7 is taking the integration. We're looking at a trig function. Please always remember, we do not know what we're going to have on the AP test. We could have trig, we could have polynomials, we could be forced to use U substitutions, and as we've been practicing most recently, working with completing the square or perchance trig substitutions. So here we go. I'm going to separate it because I can see I have 2 terms. So I'm going to go dx pi over 4 to pi over 2 minus And then I have pi over 4 to pi over 2, and I have cosecant squared x dx. This is going to give me 2x from pi over 4 to pi over 2, minus double negative, because negative cosecant squared is cotangent. It's cotangent x from pi over 4 to pi over 2. And I'm now plugging in my values. When I plug this in, I end up with pi, and I'm subtracting pi over 2. Fundamental theorem of calculus, f of b minus f of a. We're then adding cotangent of pi over 2 is 0. Cotangent of pi over 4 is negative 1. Minus 1 for positive 1. And I'm going to get pi over 2 minus 1. And this would be my exact answer. And if you were working with a decimal, 0.57079, and you can truncate or round. This brings me to number 8, the last one for this part of my video. And we are looking at the integration from 1 to 3 of e to the 3 over x power. Then we have x squared and dx. I'm going to let u equal the 3x to the minus 1 power, which means that I end up taking my derivative, and I'm looking at du equaling 3 over x squared with a negative in front dx. So I just subtracted 1, divided by my new power, and then simplified it. That means I'm looking at negative 3, 1/3, du is equal to 1 over x squared dx, and that now allows me to look 1 to 3 of e to the u, and you notice this 1 over x squared dx is the du, so I'm going to put negative 1/3, 1 to 3, e to the u du. This is negative 1/3, e to the u, and that was e to the 3 over x from 1 to 3. I'm now plugging in the 3 first. This is now negative 1/3 e to the first power minus e to the third power. And when I distribute the negative, I get e cubed minus e all over 3. And that is my exact answer. And that's what I'm looking for. Alrighty. Thank you very much, Hornets. I hope this has helped. Please be aware, in my installment number 3 for this assignment, I will be looking at numbers 9 through 12. If you have any questions, please remember to come in. Hopefully this was acceptable, and if you liked it, please make sure you click like. Otherwise, please feel free to give me constructive criticism so I may improve. Thank you very much. Take care, Hornets. Be well, and cheers.